We're live from Lindau, Germany, the site of the 74th Lindau Nobel Laureate meeting. It's a chemistry meeting this year. I know I've said that many times, but maybe this is the first video you've seen and not the 10th one that I've done. So I feel repetitive, but it is a chemistry meeting, and there are 30 Nobel laureates here this week. Mixing it up with more than 600 young scientists from more than 80 countries. And I'm delighted to be talking to Ebubechi Nwaubani. And so you're Nigerian, but born in Houston.
Yes, sir.
Where I grew up.
Nice.
Where how long did you go to high school in Houston?
So I was actually in Houston for a hot second. My mom was just there for some medical school studies, and I happened to be born there. And then she moved right back to New Jersey, where I grew up, before moving to Florida.
Okay, so yeah, you've lived around the States a little. You mostly grew up in Florida, and then what was next?
So after Texas, New Jersey, then Florida. Florida is when I went to high school and graduated from high school. And then I went to college from there.
Where'd you go to college?
I went to Harvard.
Harvard University, okay, in Massachusetts. And what did you study as an undergrad?
Chemistry, specifically chemical biology.
And you are just finished with your undergrad?
Yep, that's correct.
And you're going to go to grad school?
I am, yep.
Where?
PhD in chemistry at Stanford University.
At Stanford. I also lived in the Bay Area in San Francisco.
Lots in common.
So chemistry, grad school?
Absolutely.
Is it just chemistry? Is it something more specific?
So the program will be just in chemistry, but I'm hoping to study similar things that I did in undergrad. So chemical biology, I have a general interest in drug design, discovery, and synthesis. But a big theme at the meeting has been branching out and diversifying your field of study. So I'm definitely really open to, switching lanes a little bit with having some reference to drug discovery and design as well. So
excellent. So tell me about your interest in science. Did you always know did you have any other career ideas? Were there other interests or passions?
Yeah, I think growing up, I kind of always had a proclivity for science and math, STEM. For a while, I wanted to be a forensic pathologist. I wanted to, go a medical route. But I was really interested in the analysis and the kind of study aspect of it, the really academic aspect of it. So I actually went to college and I was pre-med at first, but that didn't last too long.
That was that same.
It did not last too long. I took my first.
Why not? Why not pre-med?
Well, it wasn't that I necessarily hated anything about it or that I didn't think I could do medical school or anything like that. It was really that I took some research courses and I started doing research, and I realized that I like that side of it, specifically creating the medicines as opposed to administering them. So I kind of switched focus, still really integrated into translational sciences and medicine, but just a different side of it. So actually something that was said at the meeting really resonated with me is at one point a laureate on stage said that our job is to make sure people go home from the hospital. And I think that's the same thing that doctors do, to make sure that people go home from the hospital. And I just am on a separate side of that, at least with my present interests. So I came to college, switched from pre-med to a research track, and I think it took me a little bit to realize that, a PhD was where I wanted to land up. I was like, I could go and just work as a research assistant right after graduation, but I talked to a couple people, talked to some people that were in their PhDs, that had done PhDs, and realized that long-form research is what I really wanted to do after graduation.
Excellent. And chemistry, why chemistry specifically?
Yeah, that's a great.
Because chemistry isn't for everyone.
No, definitely not. Sometimes it's not even for me to this day. So, but in high school, I had a really excellent chemistry teacher. Shout out to Mr. Hunter. He did a lot to make sure that students had access to research at our school. We weren't, superbly well funded, and so it's not like we went out and had opportunities to do research. We didn't have the best lab equipment in the lab, but he stayed late nights and he did wrote grants to get money and funding for our school to get new equipment and to actually have us do in situ environmental research. And that's kind of where it started, to be honest, that kind of interest in research a little bit, and I continued that in college. And so I studied chemistry at standard level and higher level in high school because of that teacher. So the importance of teachers and mentors is something that has stuck with me throughout my life. And so I think it kind of just fell into place that I decided to go down the PhD route, and that a high emphasis on teaching and mentorship and study. So it kind of made sense for me from high school.
I'd like you to elaborate on that just a little bit, because what is it about chemistry? Tell me a little more about what you like about chemistry.
Yeah, absolutely. So whenever I think about the sciences in general, I think of like physics, chemistry, biology as a pyramid. And you can disagree with this. I'm not saying it's the right way, but it's the way I think about it. I think of like physics as the foundation. That's like on the tiny scales how things interact. Below that, you can look at like math is below that, and then even go even further, philosophy. That's the foundation of that. Right above that, you zoom out just a little bit, and now you're looking at atoms and how those are. You're not looking at quarks or the tiny little quantum particles, but atoms and how those interact and form macromolecules and proteins and material science and everything like that. And then on top of that is biology. Now you're really looking at systems, cells, and things of that nature. And I think chemistry was what came most intuitively to me. The most basic sense, you think of positive and negative charge. That's kind of where my general chemistry teaching started from. And I was like, yeah, that makes a lot of attract and repel. That was something that came super easy. And then I kind of just stuck with it. And I think a lot of it had to do with that chemistry teacher I had in high school. I'm a true believer that whatever you have good experiences in, that's something that you're going to enjoy, because you have positive memories and associations with that. So it came intuitively to me. I kind of just stuck through it through college, and here I am. So
Yeah. I like I find I don't know. I guess I found chemistry more challenging.
So
I
fair,
already
so fair.
coming into it already was in love with and knowledgeable in astronomy and physics, and when I was pre-med, and my heart wasn't in it. So by the time I got to organic chemistry, it was hard.
Right. I think your heart being in it is a big factor.
Yeah.
So I'm biased for sure in my, understanding and saying what is more intuitive. I think it's where your heart is at is what you're really going to enjoy.
Excellent. Let's step a little closer. I feel, yeah, right there. That's perfect. So you know what? Also, while we've been talking in the past few minutes, at least two groups of scientists have walked past us,
Right.
and I just wanted to point out there are a lot of interesting kinds of sessions here at the meeting, and we'll talk about the meeting some. And what this was were two groups of, they're called science walks, and they were one laureate. That second group was Stephen Chu, physics laureate and former secretary at Stanford, and former Secretary of Energy under President Obama. The first scientist to serve as a cabinet member in U.S. history, as he mentioned in the sustainability panel this morning. What that was is that's something that you had to sign up for. Did you do a science walk?
I did a science lunch.
You did a science lunch with what laureate?
David McMillan.
Okay, so what it was is one scientist and a very limited number, one laureate and a very limited number of young scientists. And they literally just go for a walk and chat. And it's not a lecture. You could talk about anything. What did you talk about at your lunch with?
Yeah, we really did talk about anything. I think one of my favorite parts of that discussion is, so I want to, and I've been working with small molecule drugs and synthesis and whatnot. And as you know, the Nobel Prize this past year was won for AlphaFold, which,
as you know, as we all know, AlphaFold and John Jumper,
exactly.
A very young, not only a young laureate. Very often the research. Sorry to interrupt you, but not only do they usually. They may have been very young when they did the research, and it may have taken decades, and then it usually is a long time before they get the prize, because it's not just for cool discoveries.
Right.
It has to, written into the DNA of the Nobel Prizes, it has to be for the benefit of mankind.
Exactly.
And you can't know until some time passes how important some things are. But in this case, his work was recent. The award was given very quickly, so he's a very young Nobel laureate. Yeah. So sorry to interrupt you, but
no worries. But it was actually a really timely and thematic meeting for me to come to, because in my recent research this past year and last summer, I used AlphaFold on some proteins and some ligands that I was working with. So can you tell me about that? Yeah, absolutely. So what is AlphaFold? How did you use it? Yeah, so AlphaFold is a machine learning model that basically has been attempting to solve this protein folding problem. It's trained on the entire PDB, and it based on the entire what? Protein data bank. Protein data bank, which is basically an online data bank of all proteins that have been crystallized or otherwise modeled using analytical methods. And while you're at it, the protein folding problem. What is that also? That's, to the non-chemist. Let me get into it. So protein folding problem, basically proteins are made up of sequences of amino acids. And for a long time, and still arguably, it's been an issue of trying to figure out how proteins decide to fold into different, because function dictates like what they do. Form dictates function. Yeah, the structure. Right. Exactly. So people have been asking, based off of this sequence, is there a way that we can figure out, okay, if this is the specific amino acid sequence, this is the way it will fold, and therefore we could figure out or have more information to figure out what the function of the protein is.
So there's the, what was the first, the sequence.
Yes.
And that determines the structure, because you know the
Exactly.
sequence, and there's certain electromagnetic and other
Right,
forces,
right.
and then the structure determines the function.
Right,
Like,
right.
yeah,
So if
I
you
like
get
that.
one, you can really, if you can really solve that first part, that folding problem, then you can get a lot of information out of that. And so there are a lot of really extensive methods that have been used to solve the form of proteins, and that gives a lot of information. Um, EM, cryo-EM, X-ray crystallography, etc. But with AlphaFold, the big discovery is that it was using machine learning and in AI to, if you input a sequence, it's able to predict what this folding is, what the fold of a protein is, which is really, really insane in my opinion, and obviously won a Nobel Prize. It was the best model that had come out at the time, and AlphaFold 3 just came out earlier this year. But I'd used AlphaFold 2 in last summer during an internship, and I used AlphaFold 3 in my research this past year. So it was really interesting to come to this meeting and actually get to speak to and ask questions to the creator of this model that I've been using in my research, and also hear a lot of perspectives on AI and how it can be useful in science in general, the positives and the negatives, and how to implement it in a way that can do net good for the research area. So we talked about all leading back to my lunch with Sir David McMillan. We talked about AI, a little bit about AI and chemistry, but you really have just general discussions and get to know these laureates during these lunches. We had a discussion about AI in general and kind of the direction and how much generative AI is being integrated into your everyday life, social media and whatnot, and kind of like our ideologies on that and what we think the best way to go about it in the future is. Lots of scary things, but a lot of positive things as well. But it was interesting to have what felt like a normal conversation, but a really fruitful conversation with these laureates about science, and then also general science topics, or cultural topics, and the way that we feel the world is going.
Excellent. It's fascinating to me. You're talking so much about your research, but you just finished your undergrad.
Yeah.
And when I finished my undergrad, I wasn't doing any research. So how does that come about? Well, it's not just because you went to Harvard, but
No, for sure.
so because not every undergraduate student is doing research. So how does that happen?
Yeah, for sure. I think definitely going to university where a lot of opportunity was afforded to me had a big part in it. And there are plenty of universities around the world that allow that. But I feel really grateful to have gone to Harvard University, where so many doors are opened and you just have to ask. And I think, especially coming in, having that research experience from high school and knowing that was something that was interesting to me, I kind of just decided to try everything. I did a bunch of different projects. I worked with electrochemistry, I worked with computational chemistry, I worked with biochemistry. I was just kind of trying to touch everything and see what I liked, what I didn't like. It was an experiment of its own, just trying a bunch of different things. And so luckily there were a lot of labs, and Boston is a biotech and pharmaceutical hub, so there was plenty of industry around as well that I could kind of test things out in that way also. So I kind of took all of undergrad to just try things, fail at things, maybe once in a while succeed in things, but really just figure out what I liked and what I didn't. And that helped me form really well what I wanted to do for graduate school. So.
Yeah, I hate to say this. Are you wearing a watch?
I am not.
I'm not. Hey, does anyone know what time it is? Okay. I have to interview a Nobel laureate in 17 minutes.
I'm jealous.
so I just realized we don't we can't see the time on here.
No worries.
I don't need much time to get ready, but 17 minutes, and that could go really quickly talking to you.
Sure,
obviously, I wish we had a little longer to talk.
No
but
worries.
That's fantastic. Did you do science fairs when you were in high school?
I did.
Yeah,
My sister
not surprised.
was objectively better than me at science fair, but I followed in her footsteps a little bit.
So what else about the meeting? So what are your impressions of the meeting in general? Anything or specific?
Yeah, I think one of the biggest takeaways that I'm taking from this meeting is a global perspective on science. I think it's easy to get stuck in a bubble of where you're working, what you're doing, who you're working with. But as we talked about before, science is a community-based project, and so I think having an understanding of what people are doing around the world, the problems people are facing, the issues people are facing around the world, to tackle it on a global level is something that has really been, expanded for me. So I really am super grateful to be here and continue to meet new people, learn from new people.
And maybe someone watching this is a young scientist, and maybe even a young scientist that might apply for this meeting. Anything you have to say to young? I mean, you're a pretty young scientist, but at least you're here and have had this experience. Anything that you want to say to young scientists?
For sure. My biggest piece of advice is just try it, just ask, just send the email. The worst thing that can happen is they say no, and you never know if you don't try. That's exactly how I ended up here. So I think just send it, try it, and see what happens.
Excellent. Well, thank you so much for taking the time,
For
because if
sure.
you're here talking to me, you're missing out on something interesting.
I appreciate you taking the time.
Yeah,
Thank you.
thank you so much, Ebubechi Nwaubani.
Yes, sir.
I got it
Yes.
without even looking. So thank you very much. I got to go interview Ben Faringa.
For sure.
I get to go interview
You're lucky.
Ben
You're so
Faringa,
lucky. You're so
a really
lucky.
amazing Nobel laureate. And thank you so much for taking the time. And we'll have more live interviews with some of the 600 young scientists here at the Lindau Nobel Laureate meeting.